So the last thing we want to use for our lesson today is some equations that actually aren't quadratic, but we can make them quadratic. We can get rid of the problems that they have by using quadratic techniques. So the first one, there's a rational expression right here, 7 over x, and it's not degree 2, so it's not quadratic yet, but we can multiply both sides by x to get rid of that fraction there. And so when we do that, that will be x squared plus 5x plus, when you distribute that x over 1 to 7 over x, these x's cancel in the numerator and denominator, so you just are left with 7. And then we have a quadratic. The only thing we have to remember is, we can solve this, we just have to remember that from the original equation, x cannot equal 0, because that would give you an undefined number. But we'll continue. We can now use the quadratic formula, so x equals -5 plus or minus the square root of b squared, which would be 5 squared, which is 25, minus 4 times 1 times 7, all over 2 times 1. So that's going to give me x equals -5 plus or minus 25 minus 28 is -3 under that radical. Pull out the I, so that's -5 plus or minus I square root of 3 over 2, and nothing reduces, so those are my two zeros. They are not going to be in conflict with this, so those are solutions to this non-quadratic. We just used a quadratic technique to solve it. Okay, something different here. This is not quadratic. This is a degree 4 problem. So you would, just as an aside, expect 4 solutions. The degree tells you the number of solutions to expect. And so what else you want to notice is that this degree, this is 4, its exponent is 4 here, and this middle term, it's still a trinomial, so that's good. It's just not quadratic, but this middle term has a degree 2. If this exponent here is half of the degree, this leading term's exponent, then you can factor it as if it were a quadratic. So, but instead of x times x, that would give you x squared. Well, you want x to the 4th. So that would be x squared, and then when you add x squared plus x squared, you get your x squared. So as long as this is half of that, so this could be 6, and that would be 3. This could be 8, and that would be 4. This could be 7, then that would be 3.5. You could have any kind of exponent you wanted. All right, so then you factor just like normal. The factors of 8, 1 and 8, 2 and 4. That subtract to be 2 would be 4 and 2, and then you need a positive 4 and a minus 2. So after you factor, then you set each of these factors equal to 0. And now we have some quadratics. Well, this is like the one we solved on the other side. There's no need to use the quadratic formula because there's only one x. There's an x that's being squared. So we can use regular old algebra. We can subtract 4 from both sides, and then to get rid of the square, take the square root of both sides. And then when you do that, remember when you take the square root, it's plus or minus, and the square root of -4 is plus or minus 2i. So those are 2 of your 4 roots that you're expecting. We come over here and do this side, you get x squared equals 2, and then the square root of both sides would give you x equals plus or minus square root of 2. So those are your 4 solutions, square root of 2 and negative square root of 2, positive 2i and negative 2i. So you have 2 real roots. These would be x-intercepts, just to review everything. And these would not show up on the graph, but you would have your 4 roots. Okay, the next one is a degree 3 problem. It's not quadratic. Well, anytime you have a degree more than 1, and you're going to have to set it equal to 0. So that's the same. So I'm going to have to move that term over and that term over. So that's x cubed minus 5x squared plus 4x minus 20. If you move Those two terms over, they change signs. Okay, and so now let's look at this technique called factoring by grouping. Some of you may have learned that when you learned how to factor trinomials, which I don't use. But factoring by grouping just means you're going to mentally group the first two and factor out the GCF of the first two. So if you look at this as x cubed and this is minus 5x squared, they share an x squared. You can pull out an x squared. If you pull out, or you're going to use multiplication, right? So if you pull out an x squared, that means if you divide out an x squared from this, you'll be left with just x. And if you divide out an x squared from that, you'll be left with just a 5. So you factor out the GCF. That plus is going to make sure it's going to hang around. And then the GCF of 4x and minus 20 is positive 4. So if you divide out a 4 from 4x, you get x. And if you divide out a 4 from negative 20, you get negative 5. So that's step one of grouping, is you factor out a GCF from the first two terms and the last two terms. But you're not done yet, because this isn't factored. There's a plus there. But you know you're on the right track when these two binomials are the same. And so basically what you're going to do is factor that parentheses out. These two terms, this term here, think of that as one thing. X squared times that one thing plus 4 times that one thing. Those two terms have the x minus 5 in common. So if you pull out an x minus 5 from that, you divide it out, you're left with x squared. There's that plus. If you pull out an x minus 5 from 4 times x minus 5, if you divide it out, it leaves you with 4. So factoring by grouping takes two factoring steps. All right, then you set each of these equal to 0, and you get x is 5. That's one root, so we're going to expect 3 solutions. There's one. And then if we solve for x, we're going to get x equals plus or minus 2i. All right, so let's take a look at this last one. How many solutions would you expect? 3. And it's already set equal to 0, so let's try this grouping method again. The GCF of the first two would be x squared. X cubed divided by x squared is x. Minus 4x squared divided by x squared is minus 4. Plus. Now look at the GCF of these two, and you better be left with an x minus 4. So sure enough, if you pull out a 9, 9x divided by 9 is x. Minus 36 divided by 9 is minus 4. So that's step one done of grouping. Then you're going to pull out the x minus 4 that each of these two have in common, times x squared plus 9. Set each of these equal to 0. So x is 4. That's one real root. And then x squared equals negative 9. Take the square root. X equals plus or minus 3i. So just both of these have one real root and 2 imaginary roots. They're degree 3. Their end behavior, if I were to graph this one, it's going to have an x-intercept of 5 and have down-up behavior like that. And these two just don't show up on the graph. It could look like that. It might look like this. I don't really know what's happening there, but I know that it has one real x-intercept and then 2 imaginary solutions. Same thing for that one.